Hello class. I hope you're ready to, let's do the graphing of sine and cosine functions today. Section 4-5, we're jumping right in the middle of chapter 4, and only going to do 2 sections here. I hope you have your notes out and you're ready to write. You might want a straight edge so you can draw some little graphs. There's possibly some graph paper around, and maybe everybody wants to get a piece of graph paper, so I'll give you just a moment to make sure everybody is ready while I take care of putting this little thing away. You need to get this copied. The title, and that's real quick, but the next board's pretty long. I want you to copy several things before we start working on it. So I'm going to go ahead and turn to the next page. And a reminder for you that x is the independent variable and is measured in radians. When we're doing the trig functions, x is the independent, and that's the way it is with our rectangular coordinate system too. But it's measured in radians, which is, you got to keep remembering that. So our x-axis is going to be measured, and you see here in the bottom part that it's the graph there, the x-axis is in pi over 2, pi, 3 pi over 2, and 2 pi. And we'll have the negatives on there in a little bit. Okay, please copy this little table. X is the top column, and there's our our angle values in different increments, mostly 30-degree increments, all the way to 2 pi. So please quickly get that copied, and then we leave the bottom, because the bottom is going to be the sine value. Now in the unit circle here, I put the 4 quadrantal points here, the ones that are on the axes. So those give us some values. In the ordered pair on the unit circle, which value is sine? The x value or the y value? The y value is sine. So on the unit circle, we'll be using the y value here. That didn't look like it was oriented very good. Let's try that again. Well, it's not. So I'm going to pause here and orient this board. Sorry that this has to be in the middle of the recording, but I can't draw those nice graphs that we need if I can't know where the pen's going to write. So, well, sorry. Hopefully you're writing those values, drawing those lines. And here we are again. Let's try drawing that circle around. That was really bad. Hope I'm not going to be sad I did this. Underline it. Okay. The sine value for each of those is the y part of the ordered pair. So at 0 degrees, I'm going to pause this thing, see if I can get not responding well. Okay, the pens are not working for me. I'm going to have to write with the pen from up there, which is like with my hand. So here we go. I've got this on here. The y values are the ones we're looking for. Those are the sine. I put the values of the angle on the unit circle. So let's see here. And there are the pi over 6 and pi over 3 values. Who remembers what the value is for this ordered pair? And actually all I want is the second part, so I'm only going to write the second part. For this ordered pair here, it's at 1/2. And for the second part of this ordered pair at the pi over 3, it's the square root of 3 over 2. 3 is not happy. Okay, so that helps me with the table a little bit. So now we can begin to put the values in the table. If x is 0 degrees, then the value for sine of x is 0. Okay, what's the sine at pi over 6? 1/2. What's the sine at pi over 3? So we're at the next angle, square root of 3 over 2. What's the value of the sine at pi over 2? That's a 1. Okay. Now, I like to go through and do the quadrantal ones so that I don't lose my place. So the value for pi is going to be 0. I'm jumping over here. The value for 3 pi over 2, which is the bottom, the 270, is -1. And then at 2 pi, all the way at the end back around, is a 0. So now let's fill in between there. It will be values of the square root of 3 over 2 and the 1/2, but we got to be careful we get them in the right order and with the right sign in the quadrants. So 2 pi over 3, square root of 3 over 2. 5 pi over 6, the next one is 1/2. Then we move into the third quadrant, 7 pi over 6, that's going to end up being negative. Right. Negative 1/2. That is what that says. Negative square root of 3 over 2. And the negative square root of 3 over 2. And a negative 1/2 finishes our chart. Okay? Because we know the patterns. We've seen the patterns. And I know that doesn't look like a -1, but it is. Okay, moving back here. Now let's graph. We have our order pairs. 0, 0. Here we go. 1/2, pi over 6 is going to be a third of the way over. Third of the way to pi over 2. And go up to 1/2. Then the square root of 3 over 2 is around 0.7, isn't it? Somewhere there. Okay, and this one goes up to 1. Now we're working our way back down. We know at pi it's 0 again, so we're coming back down. And then at 3 pi over 2, it's -1. And working our way down, back up to 0. Now I'm going to try to make a continuous line. You know what the shape is like. That's kind of pretty. All right, give you just a moment to be sure your chart's there. Show what the sine curve looks like. You remember, okay? Now, that's why those values are what they are. Now we're going to examine so that we can do this quick. Of course, we don't want to go through that table every time. Absolutely not. We're going to learn fast ways to do this, but we need to see an equation and see the parts. So, are you ready? Next page. All right, here's our general equation. You remember, we've already done general equations with functions and seen all the transformations that can happen. Things can stretch, things can go left, right, up, down, okay, flip. So here is the general equation for the sine with all the little extra places you could put a number. So please write it down. Y equals A times the sine of B times x minus C plus D. Okay, please carefully write what each of these means. That's not what I want. Here we go. Now, A, that value in front of the trig function, is going to indicate the amplitude. And amplitude is the absolute value of that number. Okay? And it is the maximum and minimum of the curve. The sine of A gives the direction. So if A happens to be negative, the graph will flip over the x-axis. So it'll be upside down. So instead of beginning up, it will begin to go down. So that's how we're going to remember how the shape goes. With the sine of that, just tells you the direction. It does it go up or down as it starts. Please notice that that says the absolute value of A. Do not tell me that amplitude is -2. It's not. Amplitude is just 2. Okay, if that A is -2. All right, I assume you have that written. Let's look at B. B indicates the period. The period is 2 pi over B. That's a little formula. So these two things are kind of like little formulas. That one and this one, 2 pi over B. That's the length of the period. The period is the length that it takes for sine to make one complete phase, which is one rotation, like from 0 to 360 degrees, or from 0 to 2 pi. Okay? One complete phase. So, the period is 2 pi over B, and please don't forget to take B out of the parentheses. There are times when you have something like it from the equation up there, in the parentheses, there's not a number out front, but in the parentheses it says 2x plus something, or 2x minus something, and that's your C, except that number has to get that factor out of it. So sometimes you have to divide through by the number in front of x, and C turns into something else that's different than what you're looking at. We'll get there. We'll have one of those examples. Okay? Start with that. So, C. C indicates the units of horizontal shift or a phase shift. So that's moving left or right. Here's the deal. Don't forget that it will be the opposite direction of the sign. This is just what has happened every time we've had something in parentheses with x. It's the opposite of that number. When we had the circles, when we had parabolas, when you have something in parentheses with the x, or in the case of the circles with the y, then that number is the opposite. Okay? So it's kind of like thinking about your root. If you've got x minus 3 equals 0, then your root is a positive 3. So same idea every time we come across that. C indicates the units of horizontal shift or a phase shift, left or right, depending on the sign, and again, it's the opposite of that sign. And our D. The D indicates the units of vertical shift, up or down, and depending on the sign. That plus D would mean it would be, if it said plus 3, it would mean it moves up 3 units. Minus 3 means down. So you know that the sign of that is true, but the one in the parentheses is the opposite. Okay. I'm going to assume you've got these indicators, A, B, C, and D, and we're going to take them one at a time and then a big combination at the end. So here we go. Here's a term you may or may not have ever heard, sinusoidal curves, or sinusoidal graph. A sinusoidal graph is both the sine and the cosine, and when we get to cosine in a minute, you'll just remember, the shape of the two is exactly the same, except the cosine's just moved over a little bit. It's the shift. It's actually a quarter shift for the cosine. So the name of this shape is sinusoidal. The reason we talk about that is because here, out in the real world, sinusoidal curves are everywhere. Think about the little machine that shows the earthquake. What is that? I can't think of the word. Or the EKGs for a heart. You see the little thing, or the radar. There's different little monitors on them. That your stereo, when it shows the sound, the little there are some of those little gauges that show a sine curve. That's just that little up and down curve. The polygraph machine, when you see that indicator, the little the needle goes up and down and draws out the a sinusoidal curve. So the shape of it is called sinusoidal, and I just need you to know that word, okay? And it applies for both the sine and cosine. So here's the sine curve, and we're going to put it on here quickly. You may see the little blue dots. But I want you to see something before I trace it. That here is the little indicator that I'm going to explain to you of the shape of sine, and then we have another one for the shape of cosine. You may or may not have heard this, but this is I, me. Now, you notice that first M is big, and the second M is little. Well, the big M stands for maximum, and the little m, what do you think? Yep, the minimum. So, I's stand for intercepts. So it intercepts the x-axis or the midline. Sometimes when there's a vertical shift, the midline, which is your x-axis at this point, moves. And so that's a midline intercept. We'll see that later. So the little key for sine is I mean me. If you have that little mnemonic device, you can show the shape of sine anytime you need it. So at the beginning, there's an intercept. So I'm now going to highlight that if you can't see the point. At the beginning of the curve, there is an intercept. In the middle of the curve, there's an intercept. At the end of the curve, there's an intercept. So see 3 red dots. Now, in the first quarter, halfway between the beginning and the middle, there's a quarter, and that's the maximum. So the high point is here at +1. And then halfway between the last two, there's a minimum. So here's our low point. This gives you the indicating points. Please, when you draw this in, draw a curve. I have had many students who drew these in as little stick angle things, zigzags. No. Please be sure you make the curvature. Sorry, almost missed that point. Give the curvature. No, I don't count off for little squiggles like that, but if you just give me a zigzag, yeah, I'm going to count off points, because it's not. It's a curve. Okay? So, the thing I wanted you to do first off is to get the mnemonic device that you need to pretty much memorize for sine is I, me. Remembering that the big M's first and the little m's second. Now, what's the domain for this curve? Because it doesn't stop where I've stopped it. This is just the picture we've got here. We framed it. This is one phase, one period. But the domain for the whole sine curve goes where? Negative infinity to where? Positive infinity. It's everything. Okay? But the range is not everything. This is not all real numbers. How high does this go? How low does this go? Don't forget that you start the range at the low part. So the low part, it goes down to -1, goes up to +1, and stops and comes back. Bounces between those two, but does not go further. This is just, of course, the standard sine that is just this equation you see here. Okay, so there's your domain, your range, and you do need to know those. Okay, so on this page you got domain and range. You got the word sinusoidal. You should, if you ever hear that, you'll understand it. It's the shape of the sine curve. And then the mnemonic device to remember the shape of the sine is I, me. Next page, the cosine. Here's our equation. Y equals the cosine of x. Now we hadn't done a cosine yet, so let's be careful here. So start a graph. Give it just a minute. Here is the mnemonic device for cosine. That's me, mem. I know, they sound funny. Me, mem. Cosine is me, mem. Sine is I, me. You can memorize that. If you do not remember the shapes and are making any mistakes in where to start, or you're not sure, to start up, to start in the middle, okay, these are the way to get rid of all that unsurety, that you don't know. Capital M's are maximums. Little m's are minimums. And then the i's are intercepts. So in this one period from 0 to 2 pi, the cosine starts at a maximum. But maybe I need to do domain and range first. Okay? And by the way, they're exactly the same as a sine. So this is negative infinity, positive infinity. And what's the range? -1 to +1. So what's our maximum? At 0, it goes to +1. There's a point. At the middle, halfway, at pi, right here in the middle, we have minimum. So that gives us this point there at -1. And at the end of this phase, it goes back to maximum again. So at 2 pi, we're up at positive 1. What happens halfway between these points? The i's. An I stands for intercept. So it intercepts our x-axis at those points. And again, don't draw straight lines. Don't draw just from one. This is not connect the dots. This is a curve. So remember what the shape of the sinusoidal curve is. And here we're going to have some curvature to our shape. Okay? Now we got mountains and valleys here. And the intercepts are the middle of those. And the cosine curve goes from a high point down and back to another high point. That's one phase. If it had a negative in front, what would happen? It would flip totally over, and what would be first? Minimums would be first, and the maximum would be in the middle. Okay? So that's pretty easy to remember. You just need to remember the mem part that goes with the cosine. So I'm going to assume you've gotten this copied, because all we did here was pretty much make a sketch of the cosine. This is just the standard cosine curve. Okay? The standard. Now, let's see how things can change when other numbers get in there. All right, I have all the way from negative 2 pi to positive 2 pi on this graph. We're going to frame the curve. Now, framing the curve means we draw the little picture in a box of one phase, okay, one period. And then, essentially, all you do is cut and paste it to fill up the rest of the graph. So, as you're getting your graph ready, you see I've got some things around the screen. First off, our equation is y equals 3 sine x. So, I hope you have that written down. And then, in the middle up here, I've got I, me, or me, mem. Which is it? This is sine. Sine is the I, me, so there's my little mnemonic device I'm going to write at the top of every graph. I'm going to write that so I remember the shape. You write it so you remember the shape. And then I have a little list, and I will be grading whether you put these little lists on your graphs, okay? As you're doing them, this is how I know whether you got things right or not. And even if you got the numbers right there and the graph turns out wrong, I can give you some credit if you give me this little list. A stands for amplitude. And in this equation, what's the amplitude? Amplitude is 3. P stands for the period. A period is that formula, 2 pi over b. Look at the equation. What's the number in front of x? It's a 1. So 2 pi over 1 is 2 pi. So the phase is just 2 pi. Now, HS stands for horizontal shift, which is, we get that from the C number over there. Is there a number after X? No. So essentially that number is 0, so we're just going to write 0 there. Maybe, if it'll come out look like a 0. And VS stands for vertical shift. And is there a number added after the X and a parentheses over there, beyond the parentheses? No. So there's no vertical shift. So this one, my pens are not writing, so we'll just go the other way. So we want our first phase. Come out here and get I know. Sorry, I'm taking a long time. I guess we'll go red. We want to, in our, you start at the bottom. There's no vertical shift, there's no horizontal shift, so everything is right where it should be. So the midline is the x-axis, and this is 2 pi. The one phase is 2 pi. So that means it starts at the y-axis, that's kind of a dotted line, and it's going to end at 2 pi. Okay, we started and we stopped. There's from there to there is where we're going to go. What's the high point? The amplitude is the high point. How far above the midline am I going? We're going 3. So essentially we're going up to here. And how far down? Down 3. So there to -3. So do you see I kind of have a little box here. One phase is going to fit in that box. So now, let me change, maybe not. Okay, what is my mnemonic device? I can't see it. Let's go away. I, me. At the beginning of this box, it's an intercept. At the end of this box, it's an intercept. Halfway in the middle of it is an intercept. And then maximum is in this first quarter, so I go all the way up to 3. Minimum is in the third quarter, so there we are. And now I have the shape, which you can make it continuous. And cut and paste it. And this is fun if it's on the smartboard, because I can clone this. And I have another one, maybe, that we can add to it. There's my cut and paste. Now essentially you're going to just put in those points. I probably won't do that anymore for you, but that's what we're talking about. It's that same shape over and over again. So if you fill up your graph, and yes, I would like you to fill up the graph with the shape of your curve. Whatever it is, you frame it and then you fill it up. All right, moving on to the next one. Okay, new page, new function. Y equals -2 cosine 2x. -2 cosine 2x. What is the amplitude? The amplitude is 2. That's not nice. The amplitude is 2. But that's his minus. So I'm going to write myself a note that is 2 down. Say, the period. What's B? B is this 2 right here. And so I need a formula. It's 2 pi over 2, which the 2's cancel, and that gives me pi. So my period is just pi. So did it get longer or shorter than the normal? It's shortened up. So we're going to have more time to get it on this graph this time. Now, is there any horizontal shift? No, nothing's over there. Any vertical shift? No. So you're only dealing with a period change and then the direction change. So here we go. Go away. Oh, it's cosine. Is it I mean me or me mem? It's me mem. So I'm going to start at a maximum, end at a maximum, minimum in the middle, and intercepts between. But let's get this box on here. It doesn't move up or down. It doesn't move left or right, but it gets shorter. So it goes from here, the x-axis, y, vertical axis there, but it got shorter. It only goes to pi. So here is going to be one phase. Now, within this phase, what's our amplitude? It goes up to 2 and down to 2. So in that box, we're going to have our one phase. Maximum at the beginning. So here it is at the top. Maximum at the end. What's in the middle? The minimum. So down here at -2, halfway. Now, you have to half each of these. So the intercept is in this quarter, and a half of the last part right there is an intercept. So our shape. Okay. And you now know the shape, so you can continue with some points to get yourself the next phase. And then working them backwards into the negatives. You can get there. And yes, I want you to fill up the curve. Fill up your graph, sorry. So we worked it all the way across the screen. Anybody have a question? I'm not here to answer. That's somebody else. All right. Now let's see. The next screen. What does that number do? Is it A, B, C, or D? Well, that number behind the X is C. It's a horizontal shift or phase shift. It's going to move the whole thing left and right. So left or right. Now, this is kind of the hardest part. The up and down part's not hard. The left and right part messes some students up because the frame, the beginning moves and the end moves. So if you think of them together, it's not as hard. So let's see. The amplitude of this one is 1. The period, that number is 1, and 2 pi over 1 is 2 pi. So that's normal. But our horizontal shift, that says minus pi over 2. Minus means which way? The opposite of that, so it's going to be to the right. So this is going to the right. Pi over 2 units, a half a pi unit, so you've got to be careful. And then the vertical shift, there's not any. So, they're looking like E's. All right. So let's frame. We're moving the frame around. It's going to the right, pi over 2. So our y-axis is moving a half a pi to the left. So we are going to begin our work here. Normally, it would have ended at 2 pi. So think all the way over here at 2 pi, and then we need to come a half a pi back to the left. So it's going to end here at 3 pi over 2. So do you see how the beginning moved to the left a half a pi, and the end of it moved to the left a half a pi? That's the deal. Okay? Now, the amplitude is just 1, up 1, and over 1, so, up 1 and down 1, so that's not hard. So now we can get our points. Now, this is sine. Is it I, me, me, or me, mem? It's I, me, me, so we're going to put the points in there. Let's change to a different color. And we start at an intercept. At the end, it's an intercept. Now, what's halfway in the middle? Well, you can look at it and pretty much see midpoint from between those 2 blue points. It's your pi over 2. So here is another intercept. Then the maximum, because it didn't flip over, it's not a negative, is just up at 1, and the minimum is down at 1. So here's our shape. Okay, and so we can continue. It's going to be down, intercept, up, and there it fills our screen. But the red dots, now, you know about asymptotes. Those are not asymptotes. That's just a beginning line and an end line for one phase. So you don't have to have them on there, but I put them on there to indicate, because this is the method of framing the curve. Okay, quickly, 2 more. This one has lots of numbers. Let's go through them. The 2 is what? Amplitude, the 2. The period. There's a 1 over there, so the period's going to be just plain old 2 pi. Now, is that plus 1 in the parentheses with x? No. It's outside. So is that a horizontal shift? No, it is not. It's a vertical shift. Where are we going? We need to put a word with it. Up 1 unit. That was a 1. Sorry, kind of got weird. Okay, there's our numbers. Do we move left or right any? No. Our phase is from the y-axis all the way to 2 pi, so that's our normal one, so I don't have to draw any more lines. But then our vertical shift is up 1. So essentially, the midline moves up. So the x-axis moves up. So there's the midline. From the midline, I'm going amplitude 2, which means from the midline I'm going up 2. So from 1 to up 2 means I'm up to 3. And then we're going down 2, so down 2 from 1 is at -1. So you see how this time the whole picture has shifted up 1 unit. And now we can begin to put our points in there. This is cosine, so which is the shape? I me me or me mem? It's me mem, so that means I start at a maximum. At the beginning, I'm at a maximum, and the maximum is 3. At the end, I'm a maximum, so it gets a 3 again. And halfway between is a minimum. So minimum is -1. That kind of seems weird, but again, we've shifted, so there we go. All right. Then we need our intercepts, and here's the catch. The intercepts are not on the x-axis, the intercepts are on that midline. So here's an intercept, and the 3/4 is the intercept there. So you see how the intercept moved up 1 just with everything else. So here's our shape, and I'm going to skip putting it on the other side, but you could easily get it there. Anybody have a question? Ask somebody else in the room if you got lost. Again, if this is too fast, you can stop the recording, rewind it, and see it again. Or go online and watch it yourself if you can stand it. All right, the last one. This one is kind of messy. Got lots of numbers in there. And the main problem is that 2 in the parentheses in front of the x that we got to get out of there. So let's do the math part for that first. This 2 here. No, that didn't mean move. I need a pen. This 2 needs to come out. And for it to come out, essentially you have to divide this part by 2 and this part by 2, and that's really weird, a fraction over a fraction, remember? So, now, we're not dividing, we're factoring out. We're factoring the 2 out front, like that. But the math of that is essentially you divide that term by 2 to put what's left over after that 2 is divided out of it. So what's 1/2 divided by 2? Well, let's do, if you don't know the math, I'll come over, I need to find a spot. Here we go. On the far left side, we've got pi over 2, and you divided it by 2, which means you multiply it by the reciprocal of 2, which is 1/2. That gives you pi over 4. That's the number that's left when you, I just erased that, I hope that's okay. That's the number that's left in the parentheses, so it's a plus in plus pi over 4. And then there's a -1 out there, and this is minus sine. That's interesting, the i's upside down. You can deal with that. All right, so now we've transformed that, and we now can see what A, B, and C, A, B, C, and D are. What is the amplitude? Okay, I hope you didn't say -1. The amplitude is 1 because it's the absolute value of that number, but it does have a negative, which tells us something, that it goes down 1. Okay? It goes down first. So the maximum is now turned into the minimum and vice versa. Okay, the phase. The period. It's 2 pi over b, and b over there we just factored out a 2. So 2 pi over 2 is pi. Pen's not doing great. I'm sorry. And then the horizontal shift is the number in the parentheses, but it's the opposite. So it's pi over 4. Which way? Left. Huh. And then the vertical shift is the number in the back. And the number in the back is a -1, so that means it goes where? Down 1. All right. So here we go. We got to move the frame. First thing you do is move the vertical, you do the vertical shift. So we're going to move the midline down 1. There it is. Then we're going to do the horizontal shift, which is pi over 4 to the left. Now look at this scale here, and pi over 4 is half of pi over 2. So we are taking the y-axis, moving it pi over 4 to the left. Now, originally, if it was set at the place it would be, the end of the first period would be at pi. Okay, so we're looking at pi, but we need to move it a fourth of pi to the left. So it comes to here. And then the amplitude is 1. So 1 up and 1 down from there is the x-axis, is the top. And then -2 is the bottom. And I'm going to show you, highlight, this is going to be pretty wide here, but the frame is from here, there, there, and there. There's one frame. So in that one frame, we're going to put one period. What kind of function is this? It's sine, so it's I, me. Intercept at the beginning and end. Intercept halfway in the middle. You've got to be careful because halfway in the middle is halfway between 0 and pi over 2. So there's halfway in the middle. Now look at the amplitude. It goes down. So my maximum turned into a minimum. So it's now here at -2, and the minimum turned into a maximum. So it's there at 0. And one period looks like that. Okay? There's one period, and I'm assuming you can carry that through to the end of the graph. But we'll go ahead and stop. Hopefully you've seen enough that got all the things remembered that you had put on the shelf and not remembered for a long time. And here is your assignment. So I'll leave that up there. I think they can just stop the recording there, and it will just stay on the screen. Okay? All right. You have a multiple choice sheet that gives you, it's either pictures, one picture with a bunch of equations you choose, or it's the other way. One equation and more graphs, and you choose one way or the other, but that's the multiple choice sheet. Then you're to get graph paper. There's two different kinds of graph paper. There's a graph paper that has 8 trig graphs on it, 4 on the front and 4 on the back. And there's another one that has 6 on it, 3 on the front and 3 on the back. You're actually going to get one of each, because I want the first 8 done on the 8th sheet and the last 6 done on the 6th sheet. And I don't think, are there 6? Yeah, there's 6. I think tomorrow, maybe they're not. So you'll get paper and your assignment, there it is. You'll use your book and enjoy. See you tomorrow.